Right, so we have learned that Copernicus used math to prove that the Earth goes around the sun. As it does so, it spins on its axis. We learned that Tycho Brahe used math to prove that there are no crystal spheres and the heavens do change. We learned that Kepler proved the planets do not go in a perfect circle, that they move in an ellipse. And we learned that Galileo used his telescope without any math to completely and utterly annihilate what was left of the Ptolemaic system. And now we come to one of my all-time favorite guys, Sir Isaac Newton. He was a genius. He was socially awkward. He was weird. He had an interesting life where that involved everything from being a professor to a crime fighter. I'm not making that last part up, by the way. He's just a weird dude, right? Fantastically so. Uh, he studied everything from the nature of light to gravity. He invented calculus, which is crazy. Once he got a hold of a problem, he wouldn't let it go till he solved it. He would get so involved he would forget to eat. His friends would have to remind him to eat. One time, he wanted to understand why your eyes saw different colors, and the theory at the time was different colors of light apply different levels of pressure to your eye. So he took a dull needle and pressed it in his own eyeball at varying pressures to see if he saw different colors. He figured out the color spectrum. He's that guy, and this dude is amazing, right? The time period we're focused on is that he was a professor, right? And one of his astronomer friends comes to him. He didn't have a whole lot of friends, but he had some. And he's like, Isaac, we don't know what holds the planets in place. We know they move in an ellipse, right? We've got the math to back that up. We don't understand what keeps them in place. And Newton's like, I already figured that out. And his friend's like, what do you mean you already figured it out? He's like, yeah, I figured it out in my early 20s, right around the same time I invented this new math called calculus. You see, because I wanted to figure out why the planets move the way they move and how they do it, and there was no math available to figure it out. So I made up I made up calculus so I could solve this problem, and yeah, I already figured it out. And I just didn't tell anybody because, well, I just wanted to know for myself. And once I knew that was good enough, and his friend's like, well, did you write it down? He's like, of course I wrote it down. And then Isaac couldn't find the paper because his living quarters were a mess because Isaac Newton just didn't care about that kind of stuff. And he's like, come back later and I'll just rewrite it down. And his friend comes back, right? Newton wrote it down again. And his friend's like, this is amazing. You have to publish it. And Newton's like, nah, I don't really want to publish it because last time I published stuff, people made fun of me, right? And I don't handle criticism very well. I had a bit of a nervous breakdown. He really did, by the way, right? And his friend's like, it's so awesome. You have to publish it. So finally he does. It's called the Principia Mathematica. And in this book, he proposed the universal law of gravitation, which is at its base, at its core, it's super easy to understand. All the universal law of gravity says is that the more mass something has, the more gravity it has. This invisible force of attraction called gravity. So the more mass, the more gravity. And the further away you are from that object, the less its gravity affects you. It's so simple, right? It makes so much sense. So that's why the Earth goes around the sun, because the sun has more mass than the Earth does. That's why when you jump up, you come back down, because the mass of the Earth is yanking you down. That's why when you drop your pencil, it doesn't orbit around you, right? Because it falls to the Earth, because the Earth has more mass than you do. Right? It makes so much sense. And he had a bunch of math to back this up, by the way, that we won't get into, that I don't understand. I mean, once again, this is a guy that invented calculus, so of course he had math to back it up. Right? And so he said, think about a thought experiment. He's like, imagine there's a giant cannon, right? And you put a little gunpowder in the cannon and you shoot it off, and the cannon comes out and it falls back down to the earth. So then you do it again, you put more gunpowder in it, and it has more force behind it, and it goes a little further down the earth. And he's like, then imagine you just pour all the gunpowder you got left in it, and you fire that bad boy, and the cannonball, right, shoots out of the cannon, and it goes around, and it just never comes back down because its speed is keeping it in orbit, right? But the Earth's gravity is keeping it in its place. So its speed is keeping it going around, right? But the Earth's gravity is keeping it from getting flung off into space. So that's why the moon goes around the Earth. That's why the Earth goes around the sun. That's why Jupiter's moons go around it. It's one law that applies to all objects in the universe, at all times, a universal law to explain one of the fundamental ideas of creation itself. I mean, stop and think about that. That is crazy that this guy figured this out, right? A universal law. He also figured out the universal laws of motion that explain all motion in the universe, right? More laws of creation. Isaac Newton, in his own unique way, was a devout follower of God, and he really believed that by studying nature, he saw the mind of God himself, that you saw his hand at work. To Newton, of course, the universe makes sense because the universe was designed to make sense. Right? And so this is a shift in the way we view the universe. It's called the Newtonian machine universe. The universe is now logical. It's orderly. There are rules to explain it. It's not mysterious or magical, right? And there's this idea that given enough time, we'll figure out how everything in the universe works and how all the pieces fit together. And this was different. So not only did he invent calculus, not only did he figure out the color spectrum, not only did he figure out the universal law of gravity, not only did he figure out the universal law of motions, he changed the way we view the universe itself. This guy is amazing. Also, side note, not on your test, on the down low, he also studied alchemy, right? The whole turning into lead into gold stuff and trying to find the philosopher's stone. He also studied theology secretly and became an expert in biblical prophecy. He thought he figured out when the world was going to end by reading the Bible. It obviously has not ended. He was wrong on that. This was just such a weird dude, right? Delightfully so. And then eventually he quit being a professor, and I kid you not, he got a government job. It was his job to find counterfeiters. And back then, the punishment for counterfeiting was execution. And so he would wear disguises, and he would go to like the bars and pubs of London, right, and meet informants. He became a crime fighter. When he would arrest the guy, he was convicted. He would go to the executions. I mean, it's crazy, right? He invented calculus, and now he's fighting crime by the end of his life. Anyway, right? But he changes the way we view the universe. We now think we humans can figure it out, that there's logic that underlines everything in the universe, and we can figure it out. Right? And from Newton's perspective and Galileo's perspective and other scientists during this time period, this was almost like a religious experience. Right? You could learn about God from two books, Scripture and the book of the heavens, the book of the universe. And Psalm says, right? Scripture says that the heavens tell of his handiwork. Right? So there was a religious reason to pursue science as well.